Hey robot makers, how you doing? Hope you're having a good day so far. So, do you want to build your own perfect dream robot lab? Then this is the show for you. And I've also got some other exciting news to share with you later on as well. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole lot of fun along the way. So let's get over to our keynote and see what we're talking about today. So yes, it's all about building our dream robot lab. So let's get into this. So yes, today we're going to be looking at quite a few different things. We're going to look at essential tools that you need for your robot lab, the workspace itself, 3D printing and 3D printers, modeling software so you can create your own 3D models as well. We're looking at wires and supplies and all the bits and bobs that you end up buying and things that maybe you don't need as well. And we're looking at other tools and some equipment, some bench test equipment as well. So, Brian's asking now, when are you going to start on the remote control unit? I'm going to do that one, don't you worry. I just need to get a few other things out of the way first. So we'll come to that towards the end of the video as well. So essential equipment and tools. So first of all, a workbench, somewhere that you can actually work on the robots. So one of my biggest challenges when I got into this a couple of years ago, and I had one of those messages pop up on my Facebook thing the other day that said, it's been 8 years since you blinked an LED on an Arduino. So that's how long I've been tinkering around with Arduinos. Before then, I think I might have bought it a couple of months before then, and then just got around to making a little LED blink. But I had nowhere to actually work on this. I had a desk in our living room, and I had my computer on there, the keyboard, I think I had the 3D printer. It was all crammed on a kind of, 120 by, 9 by 60 centimetre desk, so not very much space at all. And it was a living space, so anything I left on there would be there all the time for everyone to see and mess with. So, it's not a great ideal there. So I used to have a robot box where I would put everything into the box. In fact, I've still got some of the boxes in this new robot lab. And I would put things away, put the lid on, and then when I was ready to come back to them, I would slide them out, unpack everything and plug everything back in. And that's not always great because sometimes you sort of squish some of your wires and things like that. Having an actual dedicated workspace where you can just work on robots, that's the sort of dream scenario. So I've been lucky enough to be able to have that in my space here. So if I go over to this wider camera, this is my sort of double workbench area. So I've got a 3D printer just out of sight here, and I've got these two great big areas that I can work on. And I've got some storage, as you can see, just over there, and I've got quite a few desk storage areas as well. And then right above my head here, I'll show you a picture of this. I've got some more storage similar to what's on the back there, but I've got all my filament and things like that stored up there too. And this space is ventilated as well, so there is an air conditioning unit just back there, so if there's any sort of fumes or anything, they'll get sucked out of the way. So let's have a look what else we've said on here. So yes, having a space to work on your robots is essential, particularly the larger robots. So when I was working on InMove, that was one of the reasons I didn't get further along with that, because it's a big robot and you need a lot of space to work on it. And you need a lot of space to assemble the bits as well. So yes, if you've got somewhere you can leave the parts and come back to it later, that's ideal as well. And if you haven't got that, options are just large boxes, large bins that you can put things in and sort of put them out the way. Particularly if they've got a lid on it, that can help protect from dust and things like that. So next up, soldering iron. So this is my trusty soldering iron. I have this for a number of years now. It's a simple mains powered one. There are other better options available. So there are some temperature controlled solder workstations which are much better, and they have a little dial on them, and you can sort of dial in the exact temperature and it'll maintain that. Whereas this just shorts the mains together and you get heat from that. And the tip on this one isn't fantastic, but I've been able to sort of learn some good soldering techniques, so my soldering is now a lot better than it used to be. So yes, it's quite a common one, that one. I think it's probably one of the cheapest ones on Amazon. So it doesn't have to be expensive. Just remember not to leave this switched on. So I always have kind of a routine. If I'm doing some soldering, I'll finish the job, I'll unplug it, and then I'll let it cool down before I move on to something else. Because if I get distracted, I'm likely to leave it on, and there's not much indication that that's actually on other than the smell of burning. So next up, files. And I've got some little files. These are perfect for SMARS robots, because if you work in any of the... let's see if I've got a SMARS robot to hand here. you're working on the wheels and you're trying to sort of file, you know, the wheel holes down, these tiny files are perfect for that. So they're only about this sort of size in length, the files, and you can also work some, you know, some of the other 3D printed parts as well, sort of smooth things out. So I quite like the flat ones, and I also like the rounded ones of these as well. They're ideal. They weren't very expensive, these ones. I think I just got them from the local B&Q, which is like a Home Depot. What are the other companies who sell these kinds of supplies? So small files are ideal for robots. I do have a large rasp as well. I don't know what it's called. Don't think I've got it to hand actually, but it's a great big long one, about the size of a ruler. Actually, I think I've got it to hand. So, oh, actually, there it is at the back of my office. If I just show you on this one here. So this is my same company as well. It's a bit rusted as well, but this one is good for very large parts and also cleaning off my soldering iron. So I'll just give that a bit of a give it a bit of a brush with that every now and again. So that's quite useful too. So let's go back to Keynote. So yes, I particularly like the circular ones and the flat bladed ones as well. So next up, clamps. So if you're doing gluing of stuff, or you just want to hold things in place while you work on them, these little clamps are ideal for that. I bought these from the same place I got the files from, and I've got a number of these. I think I might have about six or eight of these. And particularly if you're gluing something as well, you want to hold it in place, these are perfect for that. And I've also said they're perfect for holding up green screen. So I bought a green screen kit the other day, and it came with the exact same clamps in it. So they've got that nice kind of grip to them, so they've got quite a nice, you know, wide mouth, so you can really stretch them out, or they just hold things perfectly. So when I was working on the InMove, I used these quite a bit to sort of hold things in place while I was gluing the parts together. Helping hands. So these are essential if you're doing soldering, I would say. When I've been soldering the headers onto the Raspberry Pi Picos, I would typically get the header row, I would get some blue tack and push that in next to the, in fact in the MicroPython manual, they actually cover this technique, and I've been doing this for quite a while anyway, so I was quite pleased that they do this. So they actually show you, you know, using a bit of blue tack to hold in place, but you know, if you've got the helping hands, it's even better. So that's what I use there. And Brian says it's good to include a good cleaning brush to get rid of clean up all the files as well. Yes, so I do have some metal brushes. I'm not sure I put them actually, but I've got a number of small brushes as well. When I've done some soldering, I've got like a nylon brush, and I'll brush the flux away, and I've also got some PCB flux cleaner defluxing spray, so I'll use that as well to get rid of it. And that was one of the tips I'd learned from soldering. Always use a bit of flux. It can really make a difference, you know, to a good joint and a bad joint. If you just get, you know, the raw component hole, you put the pin in it, and then you just try and put some solder on, the solder is really not going to sort of flow around the part very well. So if you get some flux on both the part that's going to be soldered and the pin that's going in there, when you touch the solder to it, it'll just go, and it'll just make a perfect little solder joint. So, but you do need to remember to get rid of the flux. There's quite a few little robot projects I've got. I don't think that's one where I've not got rid of the flux, and it erodes it. You end up like with a rusty kind of rusty crud on the thing. You can get rid of it. Just get some isopropyl alcohol and a bit of a brush to get rid of that. But especially if you don't need that in the first place. So, Adam says the running joke with flux is the bigger the glob, the better the job. I like it. So yes, you can never have too much of that, and it burns away. It makes a horrible smell, but it gets rid of it. But helping hands will help you hold the part still while you do all the complicated trying to get things together. You know, the sort of soldering iron and the solder, and you can just keep the part still. This one did have more hands on it. It is looking a bit rusty there, but really the main thing is it's got that weight on it, and it's got these movable parts where you can just adjust the clamp. I don't use the magnifying glass that much, but sometimes that can be quite useful as well if you're working on something and you need to sort of get really close to it. So next up is lamps and lighting. So a movable desk lamp will help illuminate your workspace. It means you're not reliant on the natural light or basic room lighting, the big light as we say in the UK. And these are just from IKEA. These are like the cheapest IKEA desk lamps. I do have some Philips Hue lights in them, so I can adjust them as well. And I've got some settings where I can just press a button and it will switch these lamps on or turn them all off. So everything's controllable by a mobile app as well. But these are great for, if you're trying to get something just lit well so you can see the component parts or the numbers or just the detail of what you're working on. It's great for that. So I've got 2 lamps, one on each desk. And they also just help illuminate, if I'm taking some product photographs or just trying to take a good picture for the Instagram. So next up, this is an absolutely essential tool, and I love how simple this is to use. So digital calipers, this is one of my favourite tools. So when I'm doing some 3D modelling, say I've got a new part, say I'm going to be doing a new video on potentiometers very shortly. So say I want to model this potentiometer in Fusion 360, I'll get my calipers out and I'll just start measuring all the different, parts to this and then just make some notes of it. And then that means that when I model that in Fusion 360, it's completely accurate. And this thing is so accurate, it's tenths, hundredths of millimeters in accuracy. So that means that we're going to end up with a part that's very, very accurate in our 3D model. So when we then print that out on our 3D printer, these things fit just like a glove. So if I show you an example of that. So this is the Smars Pico robot that I printed this part for the other day, and you can see there that there's a little printed circuit board there, this little red one. If I just pull that out, that's perfectly measured to fit in there, and I've not done anything to that, and then it fits in, friction fit, and it's going to stay in place because it's just the perfect size. And I love that about having a 3D printer, having some digital calipers, and just being able to use the modelling software to bring that all together. So you can, with the digital calipers, there's a couple of different ways that you can use these. And I wasn't 100% familiar with them. I just thought you just use the sort of mouth part, but it's got these other parts as well. And there's also a sort of pointy bit at the end. So I'll quickly go through this. So if I've got the digital calipers there, and they just use little coin cell batteries in there. I do believe when you switch this off, it just turns the display off, but it is still using battery. So you will find that these batteries don't last forever. So if I measure in, say, that wheel diameter there, I can just bring that across and I can measure the the diameter of that. So that says 17.24, for example. If I measure it that way, I might get a slightly different reading. So that's 18. So it's probably about 18 millimeters. That's the diameter probably of that wheel. So if I want to measure the inside of something, so I've got this scoop here, if I want to measure the inside of that, I can't really do it with this because I'd have to guess, so that's where these are useful. So you can just do that, and then it will give you the inside measurement, so that's 37.65. And then there's this pointy bit at the end, so as you're moving your calipers up and down, this little pointy thing, so that's great for measuring depth. So I've got a little cutout area inside here. You can just see there's like a little bit of depth, so if I just move this thing just to get to the depth there, I can show you that. So this is just going to stick out, and I'm just going to, if I do it to the end there, put that down, and we get the depth. So it says there 1.7 is the depth, and I think that's pretty much correct when I was creating this. So digital calipers are an absolute must. They're quite cheap to come by, and yeah, I don't think this is a particular famous brand that I bought of digital caliper. They've got a conversion table on the back as well. I don't think I've ever used that. The battery, in fact, you don't really need to use that, because on the top there's a little button, and that will convert it from metric to inches. If I just press that little blue button there, it'll automatically convert that to inches or centimeters and millimeters. And the zeroing part is if you close the mouth there and it's not quite set to 0, you can press that yellow button and it will just zero it again. So, and of course there is always the actual measurements on the inside there. You can actually read them off if the battery went and you was in the middle of doing something, so you can actually see the measurements there as well. So digital calipers, an absolute must if you're doing any kind of 3D modelling, any kind of design, and you want to bring that in. So I love my calipers. Okay, next up is cutters and pliers. So None of them are actually pliers. If I just grab some pliers off there, off my wall. So I've got some pliers here, I've got some long nose pliers. Again, they're all looking very rusty, these. I don't know why they're so rusty. And then there's some other sort of more delicate ones as well that I use. So they're great for just holding parts in place while you're doing things with them, maybe soldering. And the cutters, obviously, for cutting stuff. So the blue ones, I've got 3 pairs of them. So every time I buy a 3D printer, and I think I bought a pair off Amazon, and they are dirt cheap. So they probably cost less than £1 to buy. I'm sure you could get them on AliExpress for that kind of price. And I've got some more substantial ones there. The yellow ones and black ones are branded, so there's quite a big chunk of steel in them, so they're great. Whereas the blue ones are designed for more cutting components, and also 3D printed stuff as well, so cutting filament. So typically when I'm getting my little SMARS robot and I'm pushing them pieces of filament into the to the tracks, there'll be a little piece of filament, then I'll just snip it with those blue ones. And I usually do that when I'm cleaning my 3D printer. I've switched it on, it's got up to temperature, and a tiny bit of filament will ooze out the nozzle. I'll just get them blue ones and just snip that off, just so I've got a nice clean surface to build from. So yes, I think those blue ones do come with a lot of 3D kits. So the past two 3D printers that I bought, which was an ANET A8 and also this Ender 3 Pro, they came with those blue ones as well. So if you like these videos, help me out by clicking the subscribe button, hitting the like button if you like the video, and if you don't, you can always click that down like. There's the dislike. I've had a few dislikes on my videos, and that does give me information as well, which direction I should take things in. And if you hit the bell, you'll get notified when I go live with videos as well. And we'll be talking more about videos at the end of the show too. And the other thing is, so I'm still going live every Sunday around 7 o'clock Greenwich Mean Time, British Summer Time, whichever we're currently in. And you can see the time zones there around the world where that maps to. So if you want to catch a video live and you interact with me on the show, that's the way to do it. I can see we've got Ovi on the show as well. Hi Ovi, hope your robot dog Destro is doing good. Good. Okay, so next up is the website. So if you've not been over to smarsfan.com recently, I have added a few extra bits and pieces on there. There's now a SMARS learning platform where you can learn Python 101, you can learn a robotics basic introduction course, and you can also learn how to build the SMARS robot itself and the quad version, the spider version as well. So head over to SMARS and have a look, see what you think of that. And give me some feedback if you think there's something missing from there, if there's more code that you want to see on there, and so on. And if you also want to help out the show, you can always go to buymeacoffee.com. And I've now started a 3-level membership. So we've got somebody who's joined the silver level. If you want to join in the bronze or the gold, go over to buymeacoffee.com/KevMcAleer and you can check out the different perks that you get for each of those different levels of subscription. And the silver one, you'll join me on a Zoom call once a week if you join that one. So I think that one's £10 per month. So not a lot of money really for what we're talking about, but it helps keep the show going, keeps me in components and stuff, and pays for all the expensive services and equipment that I use for the show. Cool, let's get back over to Keynote then. So 3D printer. So like I said, this is my second 3D printer. This is an Ender 3 Pro. The Pro just means that it's got, I think it's a 24 volt power supply rather than 12 volt, and it means it just gets the bed temperature quicker. I think that's the only real difference, to be honest, on that than the non-Pro version. But having a 3D printer means that you can print out the parts for your robot, and you've got a couple of different options there. There are so many different types of plastic filament now that you can use, and even like wood filament, and I think possibly even metal filament that you can print through a 3D printer. But PLA is by far the easiest, the most common, and possibly cheapest material that you can use. And that's actually made from sugar. It's like a fructose-based substance, so it's grown, it's biodegradable. If you throw that in the sea, it actually becomes fish food, so it's not terrible for the environment. And there's no smell when you 3D print. I have my 3D printer on most days, most of the time, and I don't get any headaches or anything like that. Now ABS, I believe, does have some fumes, and you do need to have that in a ventilated area, so that's why I would say with your robot lab, make sure you've got some ventilation. I'm indicating off over there to show you my air conditioning unit there because you need something to get rid of those horrible smells. I've not printed TPU, but I don't believe that has any kind of smell to it. And that's the sort of rubbery. I always think it's like the iPhone case type of material. So it's kind of a more malleable, pliable material, rubbery type stuff. So PLA is very easy to use. 3D printers in general are quite easy to use. I would say there are some skills that you need to pick up along the way, such as bed leveling. That can be an eternal infuriating problem if you don't master that one. So perfectly level bed is what you're going for. They're never perfectly level, so you have to just try and figure out how best to do that. So this version of the 3D printer that I've got has the BL Touch module on it, so it can drop that down automatically and you can sort of level the bed automatically and then create a little mesh where it knows that on one end it's dipped down, so it'll actually correct that in memory, if you like, so it'll adjust the motors to correct for that bit of variance. And I would say for the money, 3D printers are one of the best things that you can buy as a piece of equipment. I mean, I think the Ender Pro was probably about 250, so it's not cheap, but, you know, build quality wise, you know, fantastic. And you can pick up a 3D printer for under £100. I think my first one, the ANET A8 clone, was about £99. So you can buy them quite cheaply. And that was great quality wise. There's no issues with that. This one's just quieter and is a bit more refined. And yes, they're quite easy to maintain. Just need to keep them dust free and make sure all the parts are wiped down so you don't get any kind of build up of crud and so on. So yes, so Adam's saying there about PLA, TPU and PETG. So yes, I've not used any PETG yet. So all print on a normal printer. ABS needs a cover. Again, it's not for the fumes, that is, it's for the temperature control. Everything else needs a hardened tip. So with ABS, it can warp very easily. It's very subject to changes in temperature, whereas PLA is quite forgiving. PLA, though, is quite brittle, so if I printed my InMove robot, who is just over here, and I actually dropped that, and there you just see him there now. So I actually dropped it and it just shattered just into thousands of pieces, so it can be quite brittle, whereas ABS is obviously much tougher, but it lasts forever. So anything you print on there, you know, do think about before you do think about the environment. So yes, ABS needs a heated chamber. Thanks for that, Adam. So next up is some kind of scraper. So I do have a magnetic build surface on my printer. I'll show you a picture of that in a second. But you still get parts adhering to that a bit too strongly. So I have this little scraping tool. Let's see if I can just grab that. It's actually a cutting, it's a blade. So that's the sharp end of the blade. And this is kind of a, you know, you can swap out the different blades with this tool. But this one is just perfect for just getting underneath the edge of a part and then just slightly levering it up. So it's actually not that sharp nowadays, but it served me well, that one. I have broke the edges off slightly on that. I don't know if you can see that there, but the edges are ever so slightly chipped off the edge. But that serves me well. So that's great for getting parts off the build surface. You can use other things as well. So when I started 3D printing, I used to use this Pritt stick stuff I'd cover the glass bed completely in this stuff, or even sort of a hairspray or a, what's that spray called? Impact glue. And yeah, you just basically just spray this, but it makes everything sticky. So it's not very good, that really. Imagine just spraying your entire work surface and like hairspray, everything becomes sticky, so that's not great. And then, you know, covering the stuff with Pritt stick isn't great. I mean, this stuff, it's great for sticking paper to paper, but anything else, it's just a horrible sticky residue. And so a lot of my early 3D prints, just seeing if I can see any of them to hand. This is an example of one of them. So this surface here was printed on the Pritt stick surface. You can't see very well. Let's see if we can get an angle on it where you can see the surface is really, really bad, pitted. You can probably just about see it there. And if I touch this, it's still sticky to this day. So not perfect, not great. But I did, you know, I learned from that. So don't use that. A glass bed is great for very, very flat surfaces. You get like a nice finish on it if it sticks to it. But glass is an insulator, so if you have a heated bed, how on earth does the heat travel through the glass to get to the, so that the PLA sticks to the surface? It's going to take an age to do that, a dog's age. So I've now migrated to using these magnetic build surfaces. Now they do have a kind of funny texture to them. It doesn't feel smooth, it feels kind of rough to the touch. But when you print on them, they come out with like a mirror surface. They're absolutely perfect. And you can pull off the magnetic build surface and flex it and bend it, and the things just pop off. So I'm a big fan of them. I mean, they're about £20, I think, to buy as a surface. Glass is probably about £4 or £5, I think, for that kind of size. But the glass, you've got to attach it with like little what are they called? Crocodile clips. I've got some on my desk next to me here somewhere. Bulldog clips, that's what I'm trying to say, not crocodile clips. I can't find them. I had some bulldog clips on these, so they just clip into place, but the build surface can move ever so slightly if them clips are sort of sticking out. So the magnetic one, I think, is definitely the way to go. It just stays in place. Tom says he uses build tack, a perfect first layer. So build tack, is that similar to that blue stuff, but it's a specific brand of stuff for 3D printers? I did see that and it was very expensive, but I thought I'd rather not put down something that the print job prints to. I'd rather just have a surface that the print adheres to while it's hot, and when it cools down you can hear it crack and then it'll just pop off. So if you're using sharp things, just mind your fingers. Got to say. So there you go, there's a picture of my Ender 3 Pro with the magnetic build surface. So I think that's just the best surface that I've used to date. You can replace these without having to replace the entire 3D printer, which is great. I have had glass ones where the glass has cracked or chipped away, or if the print head has sort of gouged into it, you end up with like a pitted piece of glass. So I didn't think it would do that, but the heat can affect it. So one of these, I have had one of these on this particular printer. The head, when it was at full temperature, just pile drive straight down into the build surface and melted one of them. So I have gone through at least 2 of them. But yeah. So Tom is saying the build tack is a surface similar to the Ender. Yes, so having a properly engineered surface that's designed for 3D printers, designed for that heat change, and designed for adhesion, that's the way to go. So I would say these build surfaces are better than glass. Even though it feels rough to the touch, you come out with a mirror surface just like you would with glass. And they're not too expensive for the life of that particular build surface. I have heard that over time the magnetism can wear off, but I think we're talking a few years of that. I've not had any problems, and I've had this printer about 2 years now, I think. And they're easy enough to replace and just buy a new one. You can buy branded ones or unbranded ones, and so on. And then Octoprint. So with my 3D printer, I've paired this with a Raspberry Pi. So I've got a little Raspberry Pi like this one. I think this is a Raspberry Pi 4. You can tell by the, that's hot actually, by the connectors on there. And I've actually got a Raspberry Pi 3 that's running my 3D printer, but it's the same kind of shape as that one, the B+, I think they call that. So I've simply got a USB cable going from that to the front of the Ender, and then this is connected via Ethernet to my network. So it means that I can free up a machine, and this can just be dedicated to sending all the G-code to the printer, and I can also just browse onto that 3D printer, and using this software you can see on the screen there, I can see where it's up to, and I can also get at that over my Wi-Fi network, so I can check on my my phone to see what the status of that particular build is up to if I'm not next to it at the time. Though you probably shouldn't leave your 3D printer unattended for large periods of time, because they can set on fire. That has been known to happen. Though if you've loaded the Marlin firmware in there, it does have a thermal runaway protection. So a lot of the original ones, I think the original factory default Ender doesn't have thermal protection, thermal runaway, and what that means is the wire that comes down and that goes into the block that's the heated block that heats up the filament, it has a temperature sensor built into that. So there's essentially a couple of wires. One is for the the raw mains to go in there and melt the thing and short together to make the temperature, and then there's the temperature sensor. And the idea is there's a feedback loop. So as this gets hotter and hotter and hotter, when it reaches the correct temperature, say 200 degrees, the temperature the temperature sensor will then send the signal back to the microcontroller that's running the 3D printer and say, turn off the heated bed now, turn off the heated element now, we've got the right temperature. But then as the temperature drops, it will then say, turn it on, and then it goes back up. So you'll see the temperature sort of bounce around. But the problem is if sometimes in the code, if they haven't got a protection there that just checks that thermal runaway isn't happening. And what runaway is where the temperature goes up and up and up and up, and that thermal, the temperature sensor, if that's actually broken and isn't detecting any temperature, then it's going to keep going. Just keep putting more temperature, keep going hotter and hotter and hotter and hotter. For the life of the universe, it's never going to sort of adjust that. And thermal runaway protection just simply says, if it's still doing that after 3 seconds, something's wrong with that temperature sensor, kill it. And it might be 3 seconds, it might be like 5 seconds, but essentially it's like a watchdog making sure that it doesn't keep heating to infinity. And what can happen is, over time, as your 3D printer sort of moving across the bed, that little element, it's only held in place by a little grub screw, it can actually work its way out. And if that's come out, that's where you get this scenario where it's moved away from the temperature sensor and it just heats to infinity. So you definitely need thermal runaway protection. And the Malin 2 software, it's built into that. So if you flash your printer with that, you should be fine. So yes, the ANETs didn't have that originally. I had to flash the Malin software onto an Arduino because that's how they're powered inside. They have like a very similar 18 mega chip, and yeah, you could flash that onto the chip. So so Tom says his printer is completely self-made, 9th generation. That is awesome. I've often thought about that. Before I bought my first 3D printer, I did have a go. I had some 20mm extruded bar, and I just cobbled it all together, but I had no tools for making this properly. So it did work. I had all the wrap connectors and things, little motherboard thing, and it would have got there, but I thought I'd best just buying one of these things and then I can print a better one. But in the end, I just bought an Ender Pro and I'm happy with that. So good on you for doing that though, Tom. That's pretty awesome. And Adam says, I've got an ANET ET4 Pro rebadge that works okay. I think the ANETs are a great design. They're based on that Prusa, and they're a very good design. I mean, the Ender Pro has just one motor on one side, just so that the 2 bars that go up, only one of them is motorized. So the bar that's going up, in theory, could tilt, but it doesn't tend to do that. So it's fine. Whereas the Ender has the ANET has 2. So 2 little screw threads, so the bar will always be level in theory. So that's what I've got to say about 3D printers. One of my favourite things that I purchased is the 3D printer. I get so much joy from that little device in the corner. So I also have the 3D printer and the Raspberry Pi Pico on one of the little plugs that you can turn on and off by remote control. So again, I've got a home app button that I can turn the 3D printer on, turn it off just by hitting the button on there, and it means I can make sure it's definitely off. I've got a little caretaker routine that runs at midnight that just switches everything that should be off, so I can make sure that's included in that if I've not got a long print job on. So Octoprint is free. It's a great piece of software. You can even download a pre-configured SD card image and just burn that onto the Raspberry Pi before you start it up, and away you go. You just tell it what kind of 3D printer you've got, and it'll connect to it by the serial cable. So nice and simple. It has this nice web interface, and it's got a load of plugins. So you can that bed leveling visualization you can see on the screen. That was a plugin that I downloaded, and it's fantastic. So really like Octoprint. It really just makes 3D printing easy, and it means I can take my laptop away in an evening. I'm not leaving it unattended, and what I mean by that is I'm not leaving the laptop plugged into the 3D printer and leaving my laptop unattended. I can take my expensive equipment away and leave the $30 Raspberry Pi plugged into it. So all good. Filament. So you're going to go through quite a lot of filament if you're 3D printing. So I've got loads of, it seems I've got loads of rigid ink. You tend to find a brand that you'd like and you'll stick with it. And I found that, was it Zyro was a really good make, and they don't produce any 3D material anymore. So I'm not sure what went on there. And then I switched to rigid ink. That was one of those that was heavily advertised on Amazon, and I was like, I'll give it a go. And it's pretty good quality. So you can get PLA and PLA Plus. PLA Plus is definitely the way to go. It tends to be a bit more accurate. So if you measure with your digital calipers the thickness of the filament, you'll find that some of the filament isn't consistent. It kind of goes larger and smaller over the length of the cable of the filament, whereas good quality PLA Plus will not do that as much. I believe that the granularity of it as well is better. So you end up with a nicer, finer print. So lots of different types available. I prefer PLA. I would say definitely start with PLA if you're starting a 3D printing project. Once you've got familiar with that, and if you have the enclosure, you can look at ABS, and you can look at TPU and PETG and all the rest of them. So it's good to experiment. I would definitely say get a few colours. I think one of the things that makes 3D printed robots a bit more fun is that you've got different colours. They do tend to be these very bright, vibrant colours. But yeah, it definitely makes a difference having coloured parts and mixing them. So I'll print out a robot in a solid colour, and then I might switch parts over from another solid colour one, so I end up with ones with a bit more variation in them. Just makes them a bit more interesting. So get a few colours if you can. In the UK, it's about between £20 and £30 per kilogram roll. It does tend to come in weight like that. All these boxes are 1 kilogram, so they're quite wide. But they last forever. I mean, I worked out if I wanted to sell a SMARS robot, the entire thing, it wouldn't even be £4 for the material that's on there, because it just uses so little and there's so much on a roll. So it's quite good value for money for what it is. Yeah, Steve says the really bright colours are great for showing on YouTube videos, aren't they just? They look really vibrant and interesting. So I would recommend you buy the 1 kilogram roll. That's probably the best value for money. You just got to have somewhere to store them. So what I do is I store them in an airtight container. So when you buy them, I'll just grab this one here. This one has got a see-through container. That's a Zyro. That's an original Zyro. You can see there. And I think this is actually TPU. It just says flexible. But it's inside a plastic container that's sealed at the top, and it also has, you can just see there, the little silicone pouch. And what that silicone pouch is going to do is it's going to suck any moisture out of that environment inside this bag and keep it in that little packet rather than it being in the filament. Put that back. So the reason that that's important is, as I said before, it's biodegradable, this stuff, so it rusts. So if it comes in contact with oxygen or moisture, it will start to get brittle, and it'll wear over time. So over time, if I put one of these outside and I came back to it maybe a year later, you would definitely see that the surface is not as polished, and it'll be pitted, and it'll be a bit crumbly and dusty as it breaks down. So you don't want that to happen while you've got all your expensive filament sort of sat in your environment. I am in an air-conditioned environment, so there's not much moisture in here. But if I open the door, all that wet Bolton air will come rushing in, and it will take a while, and that could again attack the filament. So I always keep it inside the bag, inside the inside the airtight bag with the filament silicone bag in there. And Adam was saying the filament absorbs water in air even if the room feels dry. Now, as humans, we're great at sort of getting naturalized and acclimatized to something, so we can't really tell if something's dry or something's damp very easily. We just acclimatize to that. These things don't care. They will just degrade. So if you're spending quite a bit of money on that and you've got quite a few of them, I would recommend just putting them in the bag. You'll see people who've got, like, you know, a rack behind them. They've got like a display of all these different coloured filaments on there, but I think they're just throwing money away if they do that. It's not going to last. When they come to print it, it'll just be a terrible print, and they wonder why it's not adhering, the layers are not adhering, it's warping, all that kind of bad stuff. So store in an airtight container. So modelling software. So you want to create your own 3D models as a robot maker, and in your perfect dream robot lab, you're going to be using some software that you're really happy with. So I use Fusion 360, that's my modelling software of choice. But there are other alternatives to that. There is SketchUp, there is Blender, which is free, there is Tinkercad, which is also free, and there is SolidWorks, and there's probably quite a few other ones, OpenCAD, and so on. So whichever one you're familiar with, I would say double down on that, really get to learn the tool, have a look and see how that compares to other bits of software. For me, Fusion 360 is a sort of Rolls-Royce software. It is free as an education or hobbyist, so I think you just need to renew that free license every year. And they have crippled it a little bit, but it's certainly manageable. So I would go with Fusion 360 and learn that. It's definitely the best software out there for modelling in my humble opinion. Once you've built your 3D model, you can share that as an STL file on somewhere like Thingiverse. That seems to be quite a common default place where people share the files. And Fusion makes it very easy. Once you've created your model, you just right click on the component and they say save as STL. So it's very simple to do that. So I use that for designing my 3D models and then saving them to Thingiverse to share with people. So what other tools that we need to look at? So some basic stuff, some screwdrivers. So I've got a little collection of screwdrivers and things just to my left over here. So I'm looking, I've got this little area just here, just behind this, which has got all my screwdrivers in. You can't see because of my microphone, you can just see that screwdriver there. So they're always just to hand, and that means that I can quickly grab a screwdriver if I need to do some screwdriving. So pliers for just holding things in place. I've got a few different types of that. I think these are my most favourite common ones. So they're just the right kind of size for if you want to, I don't know, pull some filament out of your 3D printed model, you can just grab hold of it and wherever it's gone, there it is. Just pull it out like that. So that's what I use my pliers for. I do have a ruler. I've got my digital calipers, but I also have a ruler as well. I have a metal ruler, so that if I'm marking it, it doesn't sort of, you know, a wooden one wouldn't be great. You can end up chipping away at that, and when you draw a line, you don't end up with a nice smooth line. So this is great for just generally getting the size of things. But I think when you work with things for a while, you also get a mental idea. You're like, you know, that's about 15 centimeters there, and you measure it and you think, actually that is exactly 15 centimeters. So get used to that. A Dremel. So I do have a small Dremel. I don't think I've actually got it in this room, though I might have. And that's great for if you want to sort of polish something, or you want to do some cutting, or just generally work some parts. So if I'm working on the InMove and there's some great big parts on that need to be aligned, I might use the Dremel just to sort of finish that particular piece. I have got an attachment for my Dremel, a drill press. So you get the Dremel, you sort of slot it into the top of this thing, and it's got the nice sort of wheel that moves the head down. So it's like a small drill press. But my father's got the proper, you know, garage workshop drill press. So that's the ideal thing. So if you want to do some really nice holes, get yourself a decent drill press. I do have a drill as well. I've got I can't remember the name of it. It's a branded drill, and that's got like the hammer action and stuff on it. So it's more if I'm actually working in the workshop and I'm putting some parts on the wall. So if I'm you know, putting some of these posters up, or I need to drill some holes or attach the boxes to the wall, I'll be using my drill for that kind of stuff, but not typically on the robots. I do have some scissors as well. I've got some nice sharp scissors. So if I'm working some card, or this is more if I'm doing something from demonstration purposes and I want to cut something out, I've got them just to hand. I do have a hammer as well for bashing stuff if that's needed, but one of my favourite things is my label maker. So I do have a Dymo label maker. This thing is a great little device for just quickly throwing something together. If you want to, you know, if you've got like loads of Raspberry Pi Picos and you want one to be labelled so that you don't forget what's on it, that's my Pico Cat one. I haven't got one for that one there. One of them is dead, so I might stick a thing on that to say that, you know, the I2C thing is dead on that particular thing, but it's very easy to use. It just you just type in what you want, do that, and then you've got your little sticker that you can stick on things. There we go. So I love that thing, and this one has got interchangeable cartridges, so you can put different coloured tapes in there. And they've been around for a long time. Very cheap to buy them. So I think this was about, I'm going to say £40 to £60. I don't think it was over that. But yeah, that's Kev's label machine, because you've got to label things. You've got a bit of a label. What's the word? Spree when you buy one of these things. Everything ends up with a label when you get a label machine. So they're great fun, but great to have. So parts storage. Yes, we're going to get onto that. Don't worry, Steve. We have a section on that. So first of all, wire. A bit like the 3D printing filament stuff, with wire you probably need a couple of different colours as well. So I always go for the red and black as the basic positive and negative. I always go with the convention that blue is my data pin and green is my clock pin. So if I'm doing any sort of I2C stuff, then I use blue and green cable for that. And I have some yellow and white as well. Somebody was asking what gauge these are. I have no idea, if I'm really honest. There's this American, is it AMG, American gauge? I have no idea. The smaller the gauge, I think the larger the wire. I'm not sure. I'm not sure what the convention is there, but these things are not very large. I don't know if I've got an example there. Maybe I have. So let's just measure it with our calipers. Just switch that on. I've got... this is the thing that Brian was asking about, which is going to be my, they got AWG, American Wire Gauge, that's correct. So this is going to be the SMARS remote control. So if I just measure that, it's about 1.2 exactly, 1.2 millimeters. So that's the gauge that I'm working with there. So whatever 1.2 is in AWG, that's what I recommend. I would also say, if you've got a choice, can you go for the solid core? Because it just makes it easier to actually solder these things in place if there's just one braid. If it's got many braids on there, you will find that these things end up just like skewing off in different places, and they're very difficult to get in and screw into place and things. So I would recommend, if you've got an option, go for the solid core. But get a couple of colours, get a couple of lengths of it as well, and just put it in your drawer of bits of wire. So there's my drawer of assorted wires. I think there was an episode of Futurama where he had a drawer of assorted lengths of wire, and that really tickled me because I do have that as well. So I've got a drawer full of assorted lengths of wire. So I do have the ones in that little box there, that little really useful box there, jumper wires. So they tend to have, let's grab one here. They tend to have the, that's a better example, the sort of rounded, and they have different lengths, so they have a pin on each end. So that makes it very easy to sort of plug into a breadboard. So if you've got your little breadboard and you just plug your wires one place to another, you can sort of wire things together like that. So these are designed for breadboards, and they're called jumper wires. And I also have Dupont wires, so grab one of them there. So these tend to come in like little ribbons, and you can sort of peel the ribbons apart to strip as many wires off that you need. And they have different ends to them. There's sort of male and female ends. So I'll let you guess the gender of each of these. But that one there is a male end, and then on the other end it has the female connector. And you can have male to male, female to female, or male to female cables. So this is a male to female connector cable, and this one is about, what would we guess that is, about 20 centimeters, something like that. Let's just measure this out. Yes, it's pretty much exactly 20 centimeters. You can see that. So they tend to come in a big ribbon of about 40 cables, I would say, all connected together, and you just peel them off as you need them. And you'll typically get the 3 sets in a pack. So you'll get the male to male, female to female, and male to female in a little pack. So they're great again for if you are connecting things up. So in this little project I've got here, I am using some Dupont cables so I can plug it into a Pico or something like that, or another device before I finally solder that in place. So I typically plug these in before I do any soldering. Blue tack. So blue tack is one of my favourite things. It's reusable, it's cheap, it just works. So you definitely need to have some blue tack as part of your dream robot studio, because you'll find that it just comes in useful in so many different ways. Not just sticking posters on walls or bits of things, but holding header pins in place when you're soldering, keeping things in place. In fact, this robot here, there's a blob of blue tack, I think, underneath this Pico, just holding that in place. So it can be useful in many different ways. So you definitely need some blue tack. Some Sharpies. You can never have too many Sharpies. In my opinion, I've got a small collection of Sharpies. That is no means all of the Sharpies that I have. They're just the ones I'm okay at showing people that I've got on my desk. Again, if you're doing drawings of stuff, the big thick marker is good for you know, just if you're demonstrating something to somebody, or you just want to mark up a PCB. Sharpies will write on anything, so permanent markers are great. Just don't use them on whiteboards. I've got a whiteboard over here, just behind this this camera, and that's got my calendar on that I update, and a couple of post-it notes. So I have to make sure I don't use Sharpies on that, because it'll never come off. So before we were talking about, oops, let me just go back to that there. Back to keynotes. Yes, before we were talking about Flux and removing Flux. So I use this, Maplin have actually gone out of business now, but I bought some very similar Flux defluxing stuff, PCB cleaner. So once I've done some soldering, I'll spray some of that. I've got this nylon brush that I'll brush away any remaining flux, and that will just dissolve it and eat it away. I'm not actually sure what's in that deflux stuff. I do also have isopropyl alcohol too, which is the next up. This is a general purpose cleaner. A lot of times they'll say don't use it on LCD displays, but it works beautifully on everything else I've found, particularly on plastic surfaces. So it's great for cleaning things, doesn't leave a trace, it just evaporates, and it's 99.9% pure. I'm wondering what that 1.1% is, but you know. So Tom, okay, I optimised the length of almost all the wires. That's probably a good idea. I don't think I've optimised anything yet. I've just playing around with them. So talking about wires and Dupont connectors, I have got several different kits of connectors as well. So this is some Dupont connectors. I've also got some spare JST connectors as well, which are the little white ones. Don't know if I've got any of them to hand. Don't think so. But yeah, you typically find them on like microbits and things for power. But these Dupont ones come in different configurations. So you've got like a single pin. You can have ones that they've got 4 in a row. So it's great for putting together like a little header connector. And you have a special tool. I don't know if I've got it down here. Might not have it to hand. But it's like a tool that you use to crimp the cables in place. It's kind of similar to that kind of thing, but this is for Ethernet cables. But I have one that's for crimping cables. I do also have one of these wire cutters. That's quite useful for sort of getting the right gauge, and you can sort of strim the wire and just sort of flip it round just to get a nice clean cut. They are a bit hit and miss. I've had some pain using these Dupont connectors and the crimping tool, but I think it's because I was using the wrong tool, to be honest. I was using a cheap tool. So talking about storage and things, I have these little really useful boxes. I've got thousands of these, and these have got all my resistors, my capacitors. What else have I got in there? I can probably see on there actually. I've got quite a few different connectors, LEDs, potentiometers, all the things. I was just working with some potentiometers before actually, because that's what one of my next videos is going to be about. But I've got a box full of them. And I've got quite a few breadboards as well, so you can never have too many breadboards. These things are very useful, different sizes, and they can sort of connect together. That's what these little things are on them, so they're a bit like jigsaw puzzles, and you can just sort of stack these things together. In theory, you can stack these things together. There we go. So you can make these as long as you like. but I use these for just doing little circuits, putting things together. So for example, on my potentiometer one, I've got a Raspberry Pi Pico there, I've got a little potentiometer, and I've got some jumper wires there and a little LED, and I'll just mock this circuit up there just to test something out, and if I want to make it more solid, I'll do some soldering. So yeah, hi Anna, how you doing? Hope you're having a good day. So bench equipment. So I've got a power supply. This was quite a cheap power supply from Amazon that I purchased, and it safely provides power to my projects, and I've got some control there over how much ampage I will give to the circuit, and also how much voltage. So the A and the V there, you've got coarse and fine grain. The coarse will, very large changes in voltage or ampage, and the fine grain just makes a little adjustment to that. So typically I have it at 5 volts or 3.3, and I might just dial the ampage back to about half an amp. Is that just so that it, or is that a milliamp? I'm never sure. Half of a 1, whatever that is on there, I typically have it set to that. Now what is weird with this is that to actually to check the ampage, you actually have to short the things out, and that feels really weird to do that. You would think that it would break, but it detects that it's got a closed circuit. That's what that CC is at the bottom of the display there. So when you short things together, it detects that, and it stops putting any current through that, but it does let you adjust the ampage there. So it says on there it's 0 to 30 volts, 0 to 5 amps. So I think the 1 is an amp. So a bench power supply, I think, is a must. You can get smaller power supply, such as this one. Just destroy that for a second. So this thing here is a breadboard power supply. So the idea is that you put it onto your breadboard like so. I just push this into place. So it's got some little pins that just push into the positive and negative side of the breadboard, and then you can put in the top there, DC in or a USB in, and you can just sort of connect this, and you can then adjust whether it's 5 volts or 3.3 volts on each side, and that powers the breadboard, so you've got a nice solid power going through there. But you do need to have that little barrel connector to set that up. So test equipment, multimeters are an absolute essential. I've got 2. I've got that grotty looking yellow one there that I've used for quite some time. I've got them both set on the continuity testing there, so you touch the pins together and you get a little beep sound. So that's great for just checking circuits to just see, is something shorting or is something working the way you'd expect it to. And you can also check things like resistance, the amount of current that's going through. I think you can check capacitance on some of these as well. They've got little things you can drop the capacitors into and measure what they are. But yes, essential tool just for checking things out. So one of the things I don't have is an oscilloscope. So in my dream studio, I would have an oscilloscope as well, so I can actually see in real time the signals that are propagating through some of our channels. And finally, some of the lab basics. So Steve, this is what you was asking about, storage. So I do have these really useful boxes. Behind me, I do have these IKEA, I think they are, is it Eket boxes? So the 32 by 32 centimetre, I think, they're a cube. You can fit a lot in one of them. So I've got quite a few of them around this room. So there's some big storage bins, and I also have the filament storage above me as well. I do have the pegboard, so next to me over here we've got these 3 pegboards, and they're great for just pegging things up. And you can get all these different types of connector, such as these little clips. So yes. So Pansy Night saying real storage hours. Storage hours? Storage wars. Yes. And microcontrollers. So I do have a whole range of microcontrollers. Every time a new one comes out, I buy a couple of them as well. So you can see there we've got Node MCUs, the ESP8266. We've got the Teensy, Raspberry Pi Zero, an Arduino Uno, Raspberry Pi 3, a Mega, Circuit Playgrounds. I've got a few of them now. I've got the Microbit, ESP32, got quite a few of them. I've got the ESP32 camera module as well. I've got an STM1. I've not played with that very much. It's kind of like an underpowered Arduino, I believe. The ESP8266, it's like an ESP1, I think that's called. They're absolutely minute. Just looking around, I'm sure I've got some of them somewhere on on my desk. And then we've got the Raspberry Pi Pico at the end as well, next to the Arduino. So you want a few of these because sometimes you'll find one might be easier to work with than another. So my Arduino is kind of my benchmark tool. So I can very quickly throw some code together and get something working on an Arduino, probably quicker than I can on the Pico in MicroPython. And I know I can trust the Uno to do what I expect it to do. Whereas the MicroPython Pico one, there might be some bugs in the code because this is still quite new stuff, whereas the Arduino just works. So Adam says STMs are overpowered Arduinos, not under. I thought it was the other way around. I thought they had very little memory in them. I've not played with them enough, to be honest, but I have got one there. So, community update. So what I wanted to share with you is the small robots group that we have on Facebook. That's just hit a new milestone this week. So unbelievably, we now have over 7,000 members. It's actually grown larger than that since I put this slide together. But this is just crazy. And in this SMARS Facebook community group, that's now just hit 4,000 members. So we have so many people who are passionate about robots like we are. And I'm so happy and honoured to be, part of this 7,000 strong community. So I'm thinking, like, what else can we do with this community? We've got this big audience there of people who are, really interested in what we do. What else can we do with that? So I would say if you're watching this, make sure you go into the small robots group and just post whatever project you're working on. I would love to see whatever it is you're working on, or if it's an idea. I mean, some of the people that they post to the group are quite young, and they will post like a drawing that they've done as a robot. So I remember being that child drawing a picture of a robot and thinking, I want to have that. And here I am now in my 40s building such a thing. So it shouldn't take as long as that. Maybe we can help them shortcut some of the steps there. So yes, I wanted to share that milestone with you. I think that's amazing, but I think there's a big potential there. We can do something special with that group. And also viewer feedback. So a few people asked for shorter form videos. Somebody commented the other week that they said, I don't think these long form videos work well on YouTube. Now, the data would actually disagree with that. When I go onto the the YouTube Studio, and I look at the analytics, I can see precisely which topics, which videos have done better than others. So, for example, the Raspberry Pi Pico one is one of the most popular videos that I've done, and that was because of the timing of that. So the Raspberry Pi Pico had literally just come out, and about a day later I got a video out talking about what it was, and my take on it was slightly different than everybody else's, where they were just doing a comparison and they'd not really used it, where by that time I'd actually used it because I was familiar with MicroPython and had been using that for quite some time on the ESP and the Node MCU boards and the what's it called, Circuit Python boards as well. So I already had like a good strong opinion about that and could put something different out there. And that video was one of the most popular ones, and that one was a live stream, and it was an hour long. So the difference between like short form and live streaming you can interact with me as we talk. You can't do that in a pre-recorded one. So for building communities, live stream is the way to go. But I think we can do both. I think we can work with the shorts as well. So Tom, you were saying about the you really like the shorts, and I really do appreciate your feedback on that. One of the challenges I have with doing the shorts is it takes a long time to edit them to get it to the quality that I want, but it's worth doing. So I'm getting better and quicker at editing. I will typically focus on a really small topic, and I will just give you enough information about that to make an interesting video on that. But with editing, I can also do some other things. I can perfect it so they'll be a bit cleaner. They won't have all the pauses and filler words that I use. They'll just be the information, and I can also do sound design, so I can have all the sound effects that I can't do live. I mean, I can do some sound effects live, but the number of things that I've got are not very great, really. And I have to remember to do them as well. So yeah, there we go. Sound design. So at least with editing, we can put out some more interesting content there. So I put out 5 videos, as I've said last week. So I did one about how to load MicroPython onto the Pico, how to manage files on the Pico. That came up quite a bit, and I've got some good strong feedback on that one. The how to auto start scripts on MicroPython. Quite a few people didn't know you could do that with the main.py and boot.py and code.py on other platforms. And then we looked at Rotary Encoders. So I think I put them all away now. But the little Rotary Encoders, the kind of things you have on like a 3D printer display or like a microwave oven for dialing things in. They're very simple in how they work sort of electromechanically. So that very short video shows that. And then the most popular one I've done yet out of all of them, you can just see by the number of views and the number of days old they are, the Rotary Display. So that one was really popular, and that was combining that Rotary code, combining the code that we wrote a couple of weeks ago for the Raspberry Pi Pico in MicroPython. We paired that with the Rotary controller and made a little menu display. And somebody had actually asked, could you make... Now, when people say, can you do this? I typically think, yes, we can. How can we make that into an interesting video? So somebody said, could you make a little display that displays all the Python files that are on that Pico, and you've got a little Rotary Display menu, and you can find those files and just press it, and then it'll actually run that file. So you could have like an avoid program, you've got a follow program, or maybe a different demo. And yes, you can do that. It's very, very simple. So that short video shows you how to do that. I actually spent a very long amount of time editing that video. I went through every single line of code, line by line, editing out all my breaths and everything. And it was the world's most boring video. So I actually got rid of all that. I've got the video itself. I might publish that one separately. But yeah. So what the question I've got there is, do you want more of these short videos? I knocked out about one a day last week. I want to try and get ahead of that, so I've got at least one in the bag at any one time, so that there's always a video to fall back on, rather than doing them on the day, every single day. And what about the longer form videos? Should I carry on doing those as well? Because, so for example, Brian was asking about this SMARS remote control. So I need to design the enclosure for that. I then need to write some code that brings all this together, maybe with the display as well, maybe with a rotary controller display. And that's quite a bit of work doing that, as well as knocking out all the videos. So I've got to try and think, with the time that I have available, because I do have a full-time job as well, how can I do all the things? So I'm interested to know what your preferences are. Should I not do as many live streams? Should I do maybe one a month and then just do the shorts, so that it's like 5 shorts a week? Or should I carry on doing all the things? So do the long videos, the live streams, because they're great for this interaction. I get to speak to you directly. Or should I just stick with short videos instead? So very interested in your feedback. You don't have to answer right away, but you can definitely answer in the comments. So let's have a look what people have been talking about there. I think that's everything on my little slide deck there. Yes, it is. So let's have a quick look through the comments, and I'll get on to making my next video. So let's have a look, scroll to the top there. Wow, we've got quite a few people joined. We've got 20 people watching at the moment, which I think is the most I've ever had on a stream. So thank you everybody for spending your time with me. It does mean a lot to me. So we were talking about 3D printing. There's quite a lot of comments about that. Adam was saying about he had 2 large PLA prints that shattered on me when you drop them. It's so gutting when that happens. I mean, the breaks are so clean that you can super glue them together. So that's the only good thing there. But there's nothing worse than breaking a print that took literally hours to print, probably tens of hours to print. And Adam says, do not use Sainsbury's glue stick, it's rubbish. No, I would definitely recommend not doing that. And Alan says, if you soak the part in lukewarm water and drop a drop of soap dish, it'll also remove the... I'll have to try that. One of the issues I had, though, is by putting that glue down, if you think, like if you zoomed into that with your magnifying glass, it's a really uneven surface. So when the 3D print filament comes along, it prints to that really uneven surface. So even washing it off, that'll get rid of the glue, but you'll end up with a horrible pitted surface. So, yeah, I just don't use any of that anymore. But Tom says that build Tack a perfect first layer, and it's a sheet which is glued to the print bed. Got you. And it's that surface, it's that engineered surface that some very clever people have made, a surface that makes the filament stick to it. So it must have very small little pits that make it stick to it. But when you look at it, it looks mirror surface. So awesome. Yes, it looks like the surface from the Ender, which is good. And Adam says the same thing, is a surface coated on the build plate. And Steve says, going to order one? Absolutely. So next used to be fire starters. So one of the things that scared me about 3D printing when I first got into it was some of the horrific photographs of people's beloved build stations and PCs and everything that they've got around it, just all melted because the thing had set on fire. And there was just nothing to prevent it from it would only stop heating up until you remove the power from it. And what's worse with the A-nets is that they were designed to be enhanced by people 3D printing better quality parts for the A-net. So at a certain temperature, this filament becomes fuel. It just goes up. So yeah, those things were quite dangerous. And the main cause is the heated bed, and that's why I don't have one, interestingly. So I do set my bed temperature to about 50 degrees Fahrenheit. Celsius. That does seem to work well for my prints. Josh says, am I still early? Probably not in this case. And that's probably because I put GMT and not BST on my videos. So that's something I need to think about. And Thomas says his print is completely self-made 9th generation. I'm interested to know how you delineate the generations. Is it each part that you upgrade? And Adam says he's got an A-net ET4 Pro rebadge that works great. And yes, it's a mixture of joy and frustration owning a 3D printer. So true. So the first tip for 3D printing is somehow it doesn't matter what you do, your printer will not print. Yes, that does happen. And apparently Rigid Ink have stopped production. I use Amazon Basic filament. Interesting. So yeah, Steve was saying the bright colours are really great for showing on YouTube videos, which of course they are. Nice and bright. Even this one, this doesn't have a great 3D. It looked from a distance, it looks really good, but when you look really close up, this was a really rough quality print. You can see there's some bits of filament just sticking out, and you can see the actual lines of it. I think I did a bit of a rush job on that one, but the actual surface of it is really smooth. The sort of curved surfaces are really, really nice. You can see them sort of mirror shine on that. So that's all from the Ender Pro 3. And yeah, Adam says the same thing, Rigid Ink's no more. Filament absorbs water in the air even if the room feels dry. And Adam's also a Fusion 360 user, and Tom is as well. But you can also recommend RS Design Spark. I shall have to check that one out. Good bullet set, a good micro multi-bit set. So I do have, I think I'm not away actually, my old Maplin screwdriver set. That's also something that I use quite a bit. So you've got different ends that you can change onto this. My dog got hold of it and started to chew it because it must have had a really nice texture to it, so the end is actually all gnarly and chewed up. You don't want to see that. But that lives in my little drawer just there. So what else have we said there? So Steve was saying about part storage. So yes, I have all these drawers. These are all Alex, I think they're called, from IKEA. So I've got 1, 2, 3 of them. And then I've got there's 5 big Eckert storage things there, which are the mirror of these ones over here. So there's another 5, and then we've got these. There's 12 of them, great big storage bins, and they can hold a lot of stuff. So they're a 32, 33 centimeter cube, so you can put a lot in one of those. And Adam says Dad had the old mechanical dynamo. Oh yes. We had one of those. It had like a metallic tape, and you sort of wound the little knob on it, and then you'd press it and it would sort of crunch through. They were fantastic. We had one of those too. So Plasma says hello. Adam says 0.5mm wires. Awesome. AWG. So yes, that's what I'd go for. That's what I recommend. And Tom says for his projects, blue is analog data, yellow is clock, and green is data. So I would say whatever you choose, it's good to have a standard and stick with it, because then you'll always know when you look at your design what it means. So red, black, primary power, white, yellow, primary signals, blue and brown, secondary power. Awesome. Martin's watching from Wakefield as well. Cool. Hey, Martin. And do you make your own connectors? So I did have a go at that. I have made some... the way that I do it now is I cheat. I will get something like some pre-made Dupont ones, and I will literally put some super glue on these and just stick them together so that they form like a nice little header row. Because trying to get these blasted little connectors properly crimped on there, I think only a machine can do that. I don't think people can do that. It's beyond my skill set. So I have all those connectors. I don't tend to use them if I have a choice. I'll just buy some Dupont connectors and just use them instead. So Adam said the only when there is no choice, and last I asked, exactly. And you optimize the length of all the wires, so you don't have a sorted length of wire like me. And I like connectors instead of soldering, interestingly. Yeah, so when I'm working on a project, I'll typically breadboard it up. And then even then I might use, Dupont connectors rather than soldering something up, because they are a good solid connection. And as long as there isn't too much movement on it, and it's certainly not being pulled apart, it will stay there for a long time. So a lot of the temperature sensor modules, I think I've got one over there, which is just an ESP32 with a DHT10 temperature sensor, humidity sensor plugged in with some Dupont cables, and that works just fine. So I can't remember what you were talking about, but that's what you're talking about. So Adam says, I've got some kit. I have that kit and the correct tool, but I still hate them. Yes. If you know how to use it, you will love it. I'm sure that it took you a year. 4 months left for you to go then. So then Einar says hello. So Einar is one of my colleagues from the Live Streaming Pros group. So I'm in a sort of mentor group, how to do live streaming. It's very different than doing recorded video because it is live. Things can go wrong. And you need to know how to use all this production equipment so you can quickly change between these different scenes and so on, and the overheads and all that kind of stuff. So, and even if something goes wrong, you can do that kind of stuff as well. So that's using a Stream Deck, and also having all the lighting correct as well. So these lights, these LED lights, you probably can see on that one there, there's a very slight flicker in there. And that's because those lights are going on and off very quickly. I've got a camera with a lens that's also going off very, very quickly. And if I change the colour of that background light ever so slightly, it can look terrible. If I change that to, is it a blue colour? You can see it's a lot more flickery now than if it's the red colour. It doesn't seem to flicker as much. Now you've seen that, you'll not be able to unsee it. So we learned about how to do things like that, and what kind of lens is the great lens. So this, I've got a camera with a very specific type of lens on it and a very specific type of camera that's very quick to change its focus. So when I do that, it'll change its focus to there, and then it'll change back to me. So it's that kind of lens, the blur effect where you get this nice blur and I'm nice and sharp. That's all the stuff that we learn how to do. So Anna says he's trying to relax a little on a Sunday. Sunday's my busiest day, I think, because I'm preparing for the live stream. So those breadboard PSUs don't fit breadboards, so be careful when buying them. So yeah, different breadboards. I did notice that some have different pin lengths. The spacing between the dots, the pitch should be identical, but I guess the width of them doesn't necessarily need to be. It might be different between them. So I've certainly got some breadboards that are different number of pins wide. So that's a good shout, that Adam. And yeah, Bouncing Out was saying really storage. I have no idea what that means. Storage wars, perhaps. So the DSO138s are basic starter scopes. I shall have a look at some of those. I would definitely like to have an oscilloscope. My dad used to have a massive oscilloscope back in the day. He used to be like a TV repairman, and he would have this green, like with the round screen on it as well, and it looked like there was like a biro pen in the background just sort of lighting up. I was convinced there was a physical pen behind it for years, but yeah, you could sort of see all the different signals and stuff. So yes, STM are powered Arduinos, but not under. And Adam was also saying 7,000 people, absolutely, whoop whoop. So have I designed any of my own circuit boards? I have. I designed a greenhouse computer, greenhouse robot, and I designed my own circuit. I did it in Fritzing at first, and then I think I went to something like Illustrator and just drew out the circuit diagrams by hand. And I then printed that on a laser printer, and then tried doing the heat transfer thing where you heat that with an iron. I even bought an iron just to do this because I didn't want to ruin my actual iron. Put it on there, heated it up. It did transfer the ink to that, and then I got it in the ferro fluid thing that eats away at it, that etchant thing. But it didn't work out very well. So if I'm going to do any more PCB stuff, I'm probably going to use one of those like PCB Way, is it, or JLB PCB, whatever. The ones that you always see advertised, I probably would recommend I'm going to use one of them. But I've not done a great deal of circuit design yet. It's quite cheap, isn't it, though? I don't think it's about £5 a board to do, or you can get a couple of boards. So I'm definitely going to have a look at that. So Tom really, really likes these shorts. I know. Thank you for that, Tom. I do appreciate your feedback. So Steve says he's been designing a few PCBs with easy EDA. I love the process and think different types of board you can design. I do know that with these board design software, because I've got Eagle, I've got with Fusion 360, like the paid version, you get the full Eagle as well, but you need a degree in PCB design to use it. It's pretty full on. I think for most people, something like, JLB PCB have probably got their own version of that you can use online. It's like the layers, the vias, all that kind of stuff, the routing, and the checking that it does to make sure that the things are not too close to each other and so on. There's quite a lot to PCB board design, and I don't pretend to know any of that. So Adam says, you just designed a PCB today and ordered it from JLC PCB after arguing with the Easy ADA program. So it depends. If you have a project where you need one circuit 10 times, you can create it. Yeah, like manufacturer. I do like the idea of having it built as well, so you don't just get the dry circuit board back, but you get all the components surface mounted on their pick and place as well, so that'd be pretty good. So that explains the video. Yes, exactly. yes. So my PCB was just a prototype, so now it's easy to make one up in Easy EDA and order it. So you love the format of answering one question, how to get started with MicroPython. But yes, as mentioned, not every day a video. Yeah, so that means I was also looking at, is it doable to do a video every single day? Because for a 6-minute video, you might not have to film for half an hour. I mean, I'm quite quick at actually recording the thing. I might say the things a few times, but I know when I've got a good take of it. So then the rest of the time is just editing it so it looks good. And there's usually quite a few things that need to go into the editing. You might need to do a lot of B-roll. So you'll see when I'm talking, instead of just being my head talking to the camera, I'll cut away to something else, some B-roll. So you have to film all that as well, and it has to be sort of relevant. So, and it's a bit more storytelling. You have to have like a narrative. Every single clip has to have a purpose and has to drive the narrative. So there's quite a lot to edit in a video, whereas you can just ramble on a live stream and just answer people's questions. So yes, Adam used to use Rigid Ink, which I did too. So watching from Manila, awesome. Thanks, Michael. And Adam says ferric chloride. Yes, that's the stuff for etching away, isn't it? JLC PCB. Did I say JLB PCB? £5 for 5 boards, 100 by 100. And do you get all this silk screening with that as well, and the solder guards and all that kind of stuff? Not that I want everything on Moon on a Stick. Don't do daylight as it results in burnout. So I was feeling that a bit, but I've got this other technique where I come up with at least one idea, if not 2 ideas every day. So I've got more ideas than I know what to do with. I've literally got lots of hundreds of ideas of things, and it's just picking the most relevant one. So when I ask the audience, what do you want more videos on? Do you want more on like 3D printing, on Fusion 360, designing stuff, on coding? There was definitely people said code. That's where we get stuck. So I thought, okay, that's my wheelhouse. We can switch to that. And then I said, of code, what do you want to see more of? Is it more Arduino stuff, more MicroPython and Pico? And again, people said MicroPython and Pico, that's what they want to see more of. So the Pico is quite new still. Arduino has been around a while and people are kind of familiar with that. There's loads of stuff out there, lots of good videos. Whereas the Pico and MicroPython, there isn't as much stuff out there. So if you haven't already downloaded or bought the book, the MicroPython one, that's definitely worth a look. That's on the official raspberrypi.org site. And, you definitely want to check that out. So Marvin says, how do I get started with robotics? So I've got the answer for you right away. I get asked this a lot, as you can imagine. So if you go over to smarsfan.com, so if I just load that up and go over to here, you go to smarsfan.com and you just you can sign up all these things, that little chat thing there and this little email thing there. You have the Smars learning platform. So if you click on that and you can read the advert, then there's a Robotics 101, which is how to get started in robotics. That will answer all your questions. So it's a free course and you can just simply go through it. It works on a mobile phone as well. Talks about what is a robot. We'll not go through the whole thing here. Bit of a history of robotics. That's good to understand where it all comes from, what it's all about, and so on. And you'll be able to learn how to get started in robotics. And once you've done that course, if you go back to the learning module there, you can have a look at Python. Python is one of the easiest languages to get started with. I was a bit worried about it when I've only learnt Python probably about 3 years. And then MicroPython is just a variant of Python. So once you've learned Python, you already know MicroPython. It's just the same thing, really. So yeah, Python is really easy to get into. So there's a whole course about Python there, and there's like examples of how to write a hello world program. Does it get any simpler than print brackets, speech marks, hello world? That's about as simple as it gets, really, isn't it? So if you can learn how to do that, you're on your way. And then there's like how to build a SMARS robot. So SMARS are these beautiful little robots. My favourite robot in the entire world. He's missing his track at the moment because I just pulled that out. But how to build one of them, all the different steps that you need to go through there. And then if you want to build the more elaborate spider one, or the quad robot, then there's a course on how to do that as well. So you can print all the parts out, where to get all them from, and then how to sort of fit it all together, one instruction at a time. So that's the SMARS learning platform. So I will be adding more stuff to that as time goes on when I'm not filming videos. So that was why I was asking about, I only have so much time on this earth. What should I spend my time doing? How do I best serve my audience? So I think for now, doing these short form videos, targeting very specific questions and answering those will go a long way. So that's what I'm intending to do. And I just wanted to know what your thoughts were on the live streaming thing, because I really enjoy doing these. This is the highlight of my week, is coming on here, speaking to you guys, sharing something with you that I've learned, and learning something myself, because this is what's great about the live stream, is I get to learn from you too. And if you remember at the very beginning of my videos, I always say learn with me. And that's what I mean. I don't know everything. I know a lot, but I don't know everything. And I want to learn from you guys as well. So we're all at the same kind of stage. We're building our things. Some people have different skills in different areas, and we can share what we know. And that's why it's great that we have this 7,000 people plus in our small robots group and growing, and similarly 4,000 people in our SMARS community. So there's more coming in the SMARS community as well. I know Kevin Thomas has been working on quite a few new stuff as well. He's been working on the, what was it called, the QX21, which is that, it looks a bit like an open cat, but is his own variant of that. So yes, lots of stuff going on there too. So I've rambled on for quite long enough, I think now. Hopefully you enjoyed this video and you got a lot out of it, and you know how to build, what it takes to build your own perfect dream robot lab. And I'll be interested to know what your robot labs look like too. So if you want to post me a link to a picture or share a picture in the Facebook group of your robot lab, I would love to see that. So hopefully I shall see you soon, and you'll be back for another video next week. And I'll be putting out more short videos as well. So yes, the next one's going to be about potentiometers. So you should be able to see that. And also I'll be probably doing one on one of these little things as well. Remember Big Track back in the day where you could sort of press the buttons? These things are very simple to use and very cheap to get hold of, very thin as well. So we're looking at how we can plug that into a Pico as well. So there's at least 2 videos that you'll be seeing this week. So without further ado, I shall bid you good evening, and I shall see you next time. Thanks everybody for watching. See you later. Bye bye.